capital B for blanks also. Your book, although your book, Peter Lynch is good for push down automata also. And I've used the symbols used in the book. So some videos or any other questions asked by other staff, they could have used capital B also for blank. Okay. And I've used, you can use any delimiter of your choice. So I've used 0. So let me have a delimiter here also. I want to know the end of second number also. So I'll have two delimiters. This is to separate the two numbers and this 0 to know the end. So this is how I'm going to have my input tape. And how do I want my output tape to be? I can't rewrite the same positions as in addition. In addition, we did a very simple thing. We just replaced this with a 1 and we replaced the last one with a blank. That's it. Because addition is very simple. If I represent these two continuously in continuous cells, that gives the answer of addition. So my the operation was straightforward. Just replace the blank or the delimiter in between with a 1 and just void the last one. Then it is like representing the two numbers continuously without any breaks. That will give me the output. Okay, wherein in multiplication, I don't want to disturb this position for output. What I'll do is consider the same cells, okay, same cell representation. The blanks go over here, right? From here, I'll start writing the output. Okay, so I'll not disturb anything over here. Okay, so at the end, how it will be is this is 1, 1, this is a 0, this is 1, 1, 1, and this is the 0. Okay, so all these will have blanks. This is how my output will be. After I compute, all this will be blanks. And from starting from here, I will have 6 ones. That is what is expected, right? 6 ones should be there at the end of the tape. Other remaining all cells should be blank. Okay. So this is my output product A cross B. It will be present at the end. So this cells, starting from this cell, my output will be written. Okay, and I'll make all these void. I'll turn all these blank as in when I do my computations. So I've decided how my input is going to be, how my output is going to be. Then I have to decide the logic. So what is the logic that I'll do is, I'll take the input and I have to perform the logic. This is my output representation. Okay, so in my input representation is I have 2 ones, then a delimiter, then 3 ones, then a delimiter. Am I right? All sides blanks. Now what I'll do is take this 1 for this one time. Okay, for this, take this symbol, then go till the delimiter 0, traverse right, then start copying these many number of ones from this. Then I'll take from this, start copying these many number of ones. Please understand, only ones are valid. Okay, and my number will be represented only with this unary number system. I'll have only ones. So start from this 1 after the delimiter. Okay, 1 after delimiter. This is my logic. Then I'll see the transition diagram. I'll take this and I'll start copying it over here. Okay, so how many, then I'll come back, I'll take the next one. After I've done this, I'll just come back, I'll take the next one and copy. Okay, so I'll copy 3 ones first. So after I've done this, okay, I'll move back and I'll take the second one. Then I'll come again and copy the 3 ones again over here. Okay, so this is my logic. I will transform this 1 to an intermediary symbol y, and then I'll transform it again to 1. Okay, while counting, I'll transform this to y, so that I'll hit a y. Then only when I can't hit a 1, right? It has so many ones. I don't know where my last operation was taking place. That's a very important thing. We should have a marker to segregate like where exactly the last operation was happening. So I'll have an intermediary transformation of this 1 to y, then y again will be transformed to 1 because I have to start counting again for the next one that I see. In case there are 3 ones here, I have to copy this entire chunk thrice over here. Okay, so this transformation will be there. So this is my logic. So I see the first one, then I take the second one. Just replace this first one with a blank. Okay, cancel this first one. I've read this one. I come back and hit the delimiter. Then I take the immediate next to 1 onwards and I start copying it here. So first this 3 will be copied. Okay, then I come back. I change all this. So while copying initially, these 1, 1, 1 will be changed to y. As in when I take this 1 and fit in here, I change this to y. Take this 1 and copy here, y, y. When I come back, I'll again transform all this y to 1, 1 and 1. Because it will be ready for reading for the next loop, next iteration. So this is like loop. Twice I have to loop. twice I have to copy these 3 ones. Okay, so this is my logic. Fine. So for the first one, I'll copy these 3 bits over here. Then I'll come back. For the second one, I'll again do a copying of these 3 bits. Okay, so to understand, like I can copy, see, please, even if it's a Turing machine, understand this concept. It can handle cell by cell only. It cannot copy all the 3 ones together. At the time, I can read one symbol, I can act on one symbol only. So that is another restriction we are still having. So I cannot take at a shot, I cannot take all 3 ones and write it at all 3 positions. I can read the first one. Okay, I can go and write it. So next time I should know that I was in this place. I'm supposed to read the next one. So that is why we are transforming it into an intermediary Y. So when the pointer hits Y, okay, it knows that, okay, I was here last time. So I should go back and read the second one now. So the second one will be replaced to the Y and it will go and write the second one over here. So when it comes back, it will hit the second Y. It knows, okay, I was reading the second Y previously. Now I should read the third one and so on. So that is why we are having this Y. Okay, and so when I go back, I'll replace all these Y's with 1 again. When I try to go back to read the second one, when I go to the loop, I'll try to replace all these Y's with 1 again because they'll be ready next. Okay, so I don't know when this loop ends. So I'll rewrite all these Y's to 1 again. Our understanding, our concept is twice I'll write these 3 ones here at the end. Okay, it's 3 ones. First, this 3 will be written and next this 3 will be written. Okay, so this is the logic that we are going to follow. Okay, so we'll take the tape and we'll try to write it again. So 1, 1 followed by a delimiter. 1, 1, 1. Again, I have a delimiter because I have to start writing from this place. Okay, I have to start writing from this place. I think I did a mistake. So I cannot show the. So let us have a lengthy tape so that I can show the output also. Okay, so 1, 1, 0, 1, 1, 1, 0, and all these are blanks. Okay, all these are blanks for now. All empty cells are blanks. Okay, now let me start with Q naught. So if we have understood the logic, it's very simple. Q naught sees a 1. Okay, Q naught is here. Initially, Q naught is here. So Q naught sees a 1. So what it should do, I should transit. I should transit. It has a meaning. So I am counting or I'm nullifying it. So I'll replace it with blank. Let us replace it with blank and I move to right. Okay, so this Q naught will be replaced with a blank. Q naught reads this 1 and to represent that this 1 has been read, I'll replace it with blank and I'll move forward. Okay, so where should I move to? I should move till this, I should hit this delimiter. I need not read the second one, no problem. So I'm going to loop 2 times. So the first one is read, so I should start looping and I should start reading the symbols. So this 1 is not of any importance to me. I should hit the delimiter 0. So till that position, I should move to the right. So Q1 keeps moving to the right. It sees a 1, replaces it with 1 and keeps moving right. So it has to hit a 0. Okay, it has to hit a 0. Even it's hitting a 0, I'm not going to replace or do anything. So this hitting a 0. So always for the delimiter, please have a separate state. Okay, that will help us in counting or it will help us in extending our diagram further. So always for delimiters, have a separate state. Don't write a 0, 0, R over here. Okay, have a separate delimiter state. So when I read a 0, I go to Q2. Okay, so I'm here now. So when I read a 0, I replace it with 0. I move to right. So I'm here. I'm at Q2. Okay, I'm at Q2. I'm here. Okay, so when Q2 sees a 1, what should I do? I should replace this with Y. Okay, so this is replaced with blank already. Okay, 1 is replaced. So let me write the replacements inside. So this is now a blank. Okay, so when I see the first 1, okay, what should I do? I should replace. I should know that I've read this. So I should replace it with Y. Okay, so I'll replace it with what? I'll replace it with Y and I'll proceed further. Okay, I'll proceed further. replace 1 with a y and proceed further to the right. So there is a state change. We go to Q3. Q3, where till what position should Q3 proceed further? Q3 should proceed further till it hits a blank. Okay, so till it hits a blank, when it hits a blank, what it should do? It should replace it with 1. Am I right? So till it hits a blank, it will what? It will go, it will proceed. So what I should do is see a 1, write a 1 and move forward. See a 0, 0 and move forward. Okay. So what I do is when I hit a blank, okay, there'll be a blank over here. Okay, when I hit a blank, replace it with 1 and now move left. You don't have to do anything after this. So this is replacing 1. Okay, so this is a replacing 1. Fine. So this is, I've replaced it with 1. Okay. Now what I'll do is I'll start moving left. Okay, I'll start moving left. So I have a separate state for that, Q4. So what is my target now? I should hit a Y. Remember, what should I do? I should hit a Y. So whatever is in between, I don't mind. We'll know why we are having this lead limiter while we are accepting. We'll see that. For now, I've written the first one. Now I should go and hit the Y so that I'll know that, okay, I've read this one. I should read this one now. Okay. So what in Q4, if I see a 0, I don't have to do anything. Write 0, keep moving left. If I see a 1, I don't have to do anything, keep moving left. Q4 will transit only when it sees a Y. Okay, so when it sees a Y, rewrite it with Y and go to right to read the next one. Okay, so when you see a Y, rewrite it with Y, now go to next one. Okay, now where should I go? Should I write a separate state for this? We know when I see a 1, I'll have to replace it with Y and I have to proceed further. We already have a state for that. Okay, when I see a 1, I replace it with Y and I move to the right. So we already have a state for that. So I need not include a separate state. I'll loop back to this. Okay, so when it sees a Y, I've written the first symbol. I was moving to the left till I hit a Y. When I've hit a Y, I have to start writing what? I have to start reading from the next symbol. So I already have what? I already have states and transitions for that. So I just have to loop it out. Right? So now I go here, read the second one. It is replaced by Y. It goes till it hits this blank. Okay. It goes further till it hits this blank over here. Okay. Replace this blank with 1 and keep moving left. While I keep moving left, I keep moving till I hit this Y. This is the last position. So I hit this Y. Okay. Till I hit the Y, I'll keep moving left. So okay, I've hit a Y. This was my last operation. So what should I do? I replace Y with Y and I move right 1 bit, 1 symbol. Okay, so Q2 again sees a 1. So Q2 replaces it with Y, proceeds further till it hits the next blank, replace this blank with Y, 1. Okay, now I have successfully written one loop is done. One loop, all 3 symbols have been copied over to my output positions. All these 3 done. So this is one set copied. Okay, how do I know once it is copied? We'll wait. Okay, I go to, now I'm in Q2. Am I right? So I read a Y. Okay, I read a Y. I replace it with a Y. So this is where I am here. This is the last position. So I read a Y, replace it with Y, and I go to 0. Now Q2, I'm in Q2. I see a 0. Do we have any transitions for that? No. Q2 on a 1 goes here. Q2 on a 0. Remember, Q2 on seeing a 0. That means what? 1 iteration is done. Okay, it means 1 iteration is done. So you have to go back to the next iteration. Okay, so when you see that, what will you do? So Q2 will have a separate state. Q2 on seeing a 0, write the 0, and what should you do? You should keep moving left. Okay, you should keep moving left because I have to read the second symbol to start the second loop, second iteration of the loop. So I should keep moving left. Okay. So what happens? When I keep moving left, remember what should I do? I should replace this Y with 1 as I proceed. When I keep moving left, I have to keep replacing this. So that is why we don't get it directly connect to Q0 to repeat the loop. We have an intermediary state Q5. What Q5 does is, if it sees a Y, replace y with 1 and keep moving left. So all these three are replaced. After that, I can see a 0 or 1 also. My target is I should hit this blank. That was the last operation for this loop. Okay, for this chunk, this is the last operation. So keep moving left till I hit a blank. Okay, so there is a transition, only I hit a blank. So keep moving left. So while I keep moving left, if I see a y, replace it with 1 so that these three elements are ready for the next loop iteration. And if you see a 0, ignore. Keep moving left. If you see a 1 also, ignore and keep moving left. Okay, now what happens? When it reaches this blank, when it hits the blank, a B or a blank, when it hits this blank, what happens? Replace it with blank again and go to right. So Q0 sees a 1. We have this case already, so I don't have to write a separate state transition. So I'll just loop it again. Okay, now Q0 sees a 1. Already I have it. Q0 sees a 1. What is going to do? So let us write it here separately to get more clarity. So first 1 has been replaced by blank. Now Q0 sees a 1 and it's here. For the second iteration, so this is second iteration. Okay, first iteration done. 2 times I'm going to copy 3 ones. That is, so second iteration, what is the position? So we are in this 1 now. Q0 is reading this 1 now. Okay, and first one is blank, second one is 1. Then we have a 0 delimiter. I haven't touched it. So all these three are 1 now. I've rewritten y to 1 as I traversed backwards. Okay, then I have a delimiter. I've copied the first set of ones to my output. So this is the output of first iteration. Output starts here. Okay, and then I have blanks. Now my target is I have to replace these three blanks for the next time. Okay, so I'm going to run this loop again. So Q0 sees a 1. What it does, it replaces this with a blank and proceeds to the right. Okay, so Q1 sees a 0, replaces with 0 and proceeds right. Q2 sees a 1, I have to start counting. Replace it with y. Then what? Then ignore, skip all ones and zeros. Go till you hit a blank. Okay, replace this blank with a 1. Now come back till you hit a y. Come back till you hit a y. Okay, then go again here. So when you see a y, replace it with y and it goes to the right. Now this is a pointer. Okay, replace it with y. Now go again till you hit a blank. When you hit a blank, replace it with 1. Start traversing left. So while it start traversing left, whatever else you see, 0 or 1, you skip. You start traversing left till you see a y. You have to hit a y. So when you hit a y, replace it with y and proceed right. Now replace this with y, 1 with y. So we are 3 times this loop will be executed. Okay, so I go here and replace this 1. Okay, so when I have replaced the last one, blank with 1, I'm here, I'm at Q4, right? Last blank, I've replaced it with 1 and I start moving left. Now all these are 1s, right? So I've replaced this last 1, blank with 1. I'm traversing here, all these zeros skip. This 0 is also escape. Now I hit this y. When I'm here, Q4 hits this y. Am I right? Q4 hits this y. It writes what? It writes y again and moves to right. Now, previously, till all the cases, when you hit a y and you move to right, you were seeing a 1. Now I'm seeing 0. Q2 sees 0 for the first time. Okay, what happens? Q2 sees 0 for the first time. Okay. Yes. I'm sorry. Q2 sees a 0. That means this iteration is us done. So what will we do? We'll go and see this blank, right? So blank, blank, right. Right. So I'll come back again till I hit a blank. Okay. Q2 sees a 0. This sees the 0 for a second time. So this iteration is done. So it proceeds further. Y is there. It keeps replacing y to 1 again. 1, 1, 1. It moves to left. Okay. 0 is replaced by 0. Moves to left. It sees a blank. It hits this blank now. Okay. It hits this blank now. So when you see a blank, rewrite it as blank and move right once. I was talking about this. Q0 sees a 0. Q0 sees a 0 means end of loop. Q2 sees a 0 means one iteration is done. Q0 sees a 0 means end of loop. Okay, so when Q0 sees a 0, you have to end the loop. Now, see my content of the tape. When Q0 sees a 0, what is my content? First 2 has been replaced with blanks. Okay, I still have this delimiter. All these things I have replaced with 1 when I have traversed left. I have this delimiter also. The 0 also I have. Am I right? So I have this 0 also. Then I have the output. From this point, I have 6 ones. This is my output. Okay, this is my output. Okay, so now where am I? I've hit this blank, replace this with blank, and I'm here. Q0 sees this 0. Okay, now I can't leave it as such because your machine at the end of the computation, your tape should have only what? Your tape should have only the expected output. So I should have, my tape should have only the 6 ones. All these should be cancelled. Okay, so that is why we have separate. So Q0, when it sees a 0, replace it with blank and proceed to the right. So this will be replaced with blank first, then it proceeds here. So I get to Q5. So Q5, how many ever ones it sees, keep replacing it with blank and proceed to the right. So all these will be what? Replaced with blank, blank, blank. Okay. Now everything is set. I only have this last delimiter. Now Q5, when it sees a 0, no looping and all, Q5, when it sees a 0, replace it with blank and move right. So that is your Q accepting state. Okay, so these operations, we are doing it for the tape modifications. We are not processing anything. So we are making the tape ready for output. So when the loop has ended, that means all these symbols are not valid hereafter. So I was rewriting this y as 1 because still I could have another loop. I don't know that. So that is why I had all these symbols. So when the loop has ended, loop ends when Q0 sees a 0. That means what happens? I can just nullify, I can cancel all this and I can make my tape. So finally, when it sees a 0, I can cancel this also and I can make my tape ready. So my tape will be like this, all blanks and only outputs at the end. When it's at Q accept state, all blanks and only the 6 one-digit output will be there. Okay, so this is a multiplication logic. So our logic was first number separated by first number 2 separated by a delimiter, then the second number. So for the how many ones are there in the first number, that many times I'll copy this chunk over to after this last delimiter. So these are delimiters. This is a delimiter, this is a delimiter. Okay. So after the last delimiter, I'll start copying this number of ones over here. Okay. I'll use an intermediary symbol Y to represent where I should hit and stop. So that is why I'm using this intermediary Y symbol. Okay, so this is the Turing machine representation for multiplication. Multiplication is done via repeated addition. How do addition is just copying a set of symbols, right? So 3 bits, I copy it once, then I see the loop is there for the second time also. I go back and copy the 3 bits again. Okay, so that then when the loop ends, I nullify all the representative symbols. The first delimiter, this 0 was the first delimiter, the last delimiter, and then the number of ones in between. All these I nullify. And the loop ends, and then I enter the accepting state. Okay, so this is the multiplication representation.